Hello and welcome back. In this segment we're going to be solving problems using repetition, and I want to draw your attention to the fact that learning some facts is a very different kind of learning than learning a skill. So this is kind of like learning to paint a picture, and we're trying to do it by showing you instead of being in the same place and leading you through how to make the brush strokes and develop a skill. So we're going to do this fairly free form as we show a spec and then go into the development environment and develop the solution unrehearsed, so with mistakes and all, and then go back and fix them so that you'll start to get a feel for the skill of developing the solution to a problem using loops and selection statements and the other operators that we have in the language. So learning the words in a language and learning to express yourself in the language are very different skills, and we're definitely going after the how to express yourself in the C language in this segment. Let's look at the first spec. You'll recognize it from a couple of segments ago, and we've added something to it. So we're going to, in this spec, ask the user to enter some test scores, and when they've entered all of the scores, enter -1. And so far this is the same as the last time we solved this problem. The difference this time is your program is being asked to find the average of some test scores, and we will output the sum, the number of grades that were entered, and the average of all the grades that were entered. So let's go, and I'll take this spec with me. We'll build a test case, just a small test case inside of the development environment, and we'll work from there. Okay, what we're going to do now is revisit the test scores specification, and we've changed it a little bit for this segment. I'm going to need a little bit more room, so I'm going to change my view in the development environment to full screen, and you don't need to do this. I just need you to see more lines of code at one time. So this is the code that we had before, and I've changed the spec to the new spec. So let's revisit this. We were asking the user to enter test scores, and it's a sentinel controlled loop. That means when they've entered all the scores, they're going to enter the value -1. That's the sentinel value. And the program is going to sum up all of the scores entered. That was the spec the last time. Now we're adding this part, find the average, and output the sum, the number of grades entered, and the average of the grades. So I've changed the test case a little bit. We're going to still have 3 grades, but I've changed them to 70, 80, and 100. And then enter the sentinel value. That's part of the test data. The expected result is that these numbers sum up to 250. There were 3 pieces of data entered, 3 grades, and the average of them is 83.33. So the spec doesn't say how many places of accuracy to output in the average, so I just kind of decided that we should put 2 places of accuracy. Maybe you should decide 1 place of accuracy, but we do want this to be a floating point number. So you might start to see now that we had integers everywhere in this problem except for this one, which is a floating point number, and we'll use the data type double for that. So let's go and look at the code that we had from the last time. So here's the priming read. This is outside the loop, before the loop begins, and we ask the user to enter the first test score. And then we go into the while loop, and the stop condition is while the score is not equal to -1. So you keep going until you find the sentinel value. Each time through the loop, we added the score into the sum. So this is an accumulator variable. And this is called the repeating read. At the bottom of the while loop, in a sentinel controlled loop, we ask for the next value. Go back up to the top. The first thing we do with the new piece of data is test it for the sentinel value. And if it's not the sentinel value, then we process that data. When the loop is over, we do the output of the results. And in the previous spec, the result was simply to output the sum of the scores that were entered. So let's look at the difference between this spec and the last one. We not only have to find the sum, but we also have to find how many pieces of data were entered. So we're going to add to this spec a counter variable, and it can be an integer. We're not going to enter 2.5 test grades, so we're going to have a count variable, and let's start that at 0. We have 0 grades entered so far, and every time we get a test grade that we see is not the sentinel value, so we're inside the loop now, we will add 1 to that counter. So count gets count plus 1. Okay, let's go down to the bottom and let's check that our counter is working. Put a carriage return there. No, I don't need one. I put one at the end of the previous line. You entered %I grades. We've been calling them scores, haven't we? Scores. \n, and we'll put the variable count in there. And let's see. So what have we changed so far? We added a variable, a counter variable, and inside the loop, each time we have a valid grade, we'll add 1 to the counter and then output the result. So let's see if that works. I'm going to build this with F7. And now I'm going to, let's run it without the debugger this time. So I'll take out the breakpoint and I'm going to hit F5, enter a test score. It doesn't matter. How about 4, 5, and 6? And -1, and it says that the sum of those is 15, and I entered 3 scores. That seems to work. Let's try it again and enter a different number of scores. 2, 3, 4, 5, -1, and see if it's counting correctly. The sum of those is 14, and you entered 4 scores. So our counter seems to be working. I didn't use the debugger on that. Probably I should have demonstrated that, but I didn't make any mistakes. Perhaps this is a little bit too rehearsed. I'm trying not to rehearse these, so that as I develop the solution, you see that we're working throughout the code. It's not like you start at the top and write the whole program from top to bottom. It's any more than you would paint a picture from the top to the bottom. We're working with this whole piece of code. What do we need to do now? We need to calculate the average. Well, the average is the sum of the numbers divided by how many there are. And we need a variable to put the average in, and we're going to use a floating point value, which for us will be a double, and I'll call it average. I'm not going to initialize it. Leave a blank line there. After I have the scores, the sum of the scores, and the number of scores that there are, then I can calculate the average. So average is, or average gets, the sum divided by the count. And then we'll go down here and we'll output the average. The average score is, and this is a double, we'll put %LF and a \n. And I'm typing 2 R's sometimes instead of 1. And we have a bug in here, but I want to I want to show you what this program would produce, and I said I was going to put 2 places past the decimal. Let's compile that, and we have build succeeded, and let's run it with just some simple data. Three and 4 minus 1. So the sum is 7, and we entered 2 scores, and it says that the average score is 3.00. Now there's a bug. What is 7 divided by 2? It isn't 3, unless we're using integer division. So hopefully you'll remember from a previous segment when we looked at mixed type arithmetic, what's wrong with this line now? We have a double variable here, and we have an integer divided by an integer. Some of my students who have encountered this problem would then choose to change the sum variable to a double, so that this division would happen in double instead of int. And that's the wrong solution. The sum of some integers is an integer, and you should use the data type integer for calculating that sum. This is the place where the mistake happens in the division, where we lose some data, and what we should do here is do an upcast of the variable on the left. Excuse me. So now we have, let's take double, upcast this value to a double data type, and then this one will be implicitly upcast so that the division will happen in double. So the result of this will be a double, and it will go into this double variable average. So let's excuse me, compile that, and it succeeded, and we'll run this with no breakpoints, and I'll try that simple one that we did before, 3 and 4 minus 1 to get the loop to stop. And this time we have that the average score is 3.50. So we are doing the arithmetic now in floating point. Let's go back and check our test case 70, 80, 100 and see if we get the correct average. I pushed F5, 70, 80, 100, minus 1, and there we have the sum 250. The count is 3 scores, and the average score is 83.33. Notice what I did when I was working on this problem. I didn't necessarily use a reasonable test case to get it working. I mean, 3 and 4 don't sound like test scores. What I was doing there is just seeing if the fundamental part of this program is going to work. If I can't add 3 and 4 and find out that the average is 3.5, then there isn't any chance that a reasonable set of data would be working correctly. And it's just so much simpler to get your brain around these really small numbers and see if the code has a chance of working. What we didn't get to do this time was to go into the debugger and step through the code and see what it's doing wrong. I didn't make enough mistakes this time. Hopefully next time I'll make more mistakes, because that's where more learning happens. Very good. Let's go and look at another spec now. Let's look at another spec, and this one also uses a Sentinel value and a priming read. So we're going to look at this program, which will calculate the gas mileage that you're getting. So you'll ask the user to enter the number of miles that were traveled and how much gasoline was used, and then output the miles per gallon for that tank. that part is pretty easy. Just divide miles by gallons of gas and you'll have miles per gallon. And now we're going to add the looping part. Continue to ask for the miles and the gasoline used until the user enters -1, which is going to be the Sentinel value. This is the same Sentinel value we used in the last one, only coincidentally. Calculate the overall gas mileage for this particular user. So over all tanks of gas, what was the gas mileage achieved? And we're going to have a test case here. So I've picked out some data, and also this is kind of like a sample run of what the program should do. So it will print out, enter the gallons of gas used, -1 to quit, and then what's in bold here the user will enter. So the user says 10.7 gallons and they went 136.7 miles, and then the program calculates the gas mileage and prints that out. So back up to the top of the loop then, ask the user again for the gallons of gas and the miles that they drove, and output the mileage for that tank. When the user has entered all their data, they'll put -1, the loop will exit, and we will calculate the average miles per gallon for all of the tanks of gas. And I did the calculation for this test data, so we can use this as our test case and aim at getting 11.65 as the answer to the gas mileage question. Let's go and develop that one now. Okay, looking at this next specification, what I've done so far is I've made a new project called miles per gallon and a new C file, milespergallon.c. I pasted the specification up at the top so that we can refer back to it, and I have available the test case that we're going to use, and I'll flip back and forth to the test case as we get closer to understanding the problem. So I have a minimal C program here, and compile that, make sure that we don't have any typos as we go along, and it's easier to find the problem. So let's look at the spec now. Ask the user to enter the number of miles they traveled, how much gasoline was used, and output the miles per gallon for that tank. So this is kind of like you have one tank of gas. What was your miles per gallon? And then if you want to do that over time, you're going to have lots of tanks of gas and lots of distances that you traveled, and you want to calculate the miles per gallon for your car for all tanks of gas. So that's kind of the problem that we have. And if you have a look at the test case again, here's what the program might look like as it runs. So first ask the user to enter the gallons of gas used and the miles that they drove, and then calculate their gas mileage and output the result. So it looks like the input variables are going to be floating point numbers. We have 10.7 gallons of gas and 136.7 miles. And for that tank, they got 12.78 miles per gallon. And then you see that it repeats that. Enter the gallons of gas used, enter the miles driven, and then the Sentinel value was entered on the third one. The Sentinel value is again -1. It could have been anything that wouldn't be a reasonable number of gallons of gas. And then after the loop is over, calculate the average for all of these tanks. So if we really understand the problem, we can make an example test case and show what we expect the result to be. So let's start by declaring some variables for just this first part, where we enter the information for one tank of gas and calculate the miles per gallon for that tank of gas. I'm working in full screen mode just so that you can see a few more lines of code. I don't expect your development environment to look exactly like this. Let's think carefully about what we want the variables to be so that the code will make sense as we read it. I'm going to call one miles and I'm going to call one gallons. And then we'll need another one for the miles per gallon. So let's call that when you can't think of the variable name, say it out loud what you think it should be used for, and then that's the name of the variable. It's really, if we had called that M, we would be in trouble later on trying to figure out what we meant by a variable M. So we're going to ask the user to enter the gallons of gas they used and the miles. So let's do it the way that this spec says. Enter the gallons of gas used -1 to quit. So that's the prompt. And now we'll enter, we'll scan in the, we'll scan in the gallons of gas. So we're going to use %LF because that's a double. And the ampersand gallons. Now we're going to ask for the miles traveled. Let's make it look just like the spec. Enter the miles driven. Not the spec, the test case. Enter the miles driven. And scan in using %LF ampersand miles, and then we might want to actually calculate the miles per gallon for that tank. Miles per gallon gets miles divided by gallons, and output. Now I can never remember exactly what it looks like. For this tank you got miles per gallon. Okay, for this tank you got %.2 LF miles per gallon. I hope I'm making some mistakes so that we'll have something interesting to talk about. Oh, yes, there I did make one mistake. Let's put in the variable here so that it will get output. Miles per gallon. Okay, well, there's something interesting that just happened. We can't fit that whole line of code in the window, and you probably can, but I'm using this lower resolution. So what you cannot do is break a line of C code inside of double quotes. So what I just did there will not compile ever. But you can break a line of C code in other places. So this is perfectly valid. This indentation indicates that this printf statement is not done, and that's acceptable code. What's not acceptable is if your code goes way off so that the reader of the code can't see it. So you can break the lines, but not inside the double quotes. Okay, so we haven't solved all of the spec. We've just solved one little part of it where we would ask for gallons and miles and see if it makes sense. So let's first compile with F7 and see if we've made any syntax errors, and it's kind of too bad that there aren't, because I expect that you will be making syntax errors at this point. Now let's run this and see if this part is working so far. Gallons of gas used. Well, let's suppose we used 1 gallon of gas and we went 10 miles. For this tank you got 10 miles per gallon. Well, that seems to make sense. If you went 10 miles on 1 gallon of gas, that would be 10 miles per gallon. It didn't test very much of the program though, because we didn't use any floating point, anything past our decimal point. So let's run it again and say, go over to the test case. 10.7 gallons of gas, 10.7 gallons of gas, and the miles driven 136.7. We had calculated this earlier with a calculator and found out that we wanted the answer to be 12.78, and that is the right answer according to the test case that we have here. Okay, so part of the problem seems to be solved. We have we can ask for data, calculate miles per gallon for 1 tank of gas. Now what we need to do is to work on the Sentinel controlled loop behavior. So we're going to do this over and over. We're going to ask the user for pairs of numbers, and when they've entered -1, then we'll be done. Okay, so I'm going to put my while loop right here. Make it a fill-in-the-blank problem. What should be inside the loop and what should be outside the loop. So for each tank of gas, we're going to calculate the miles per gallon. And let's fix up the indentation there. Edit, Advanced, Format Selection. Okay, so let's see what's developing here. We ask the user for the gallons of gas used before we go into the loop, and then we ask them for the miles driven inside the loop. Why did I do that? Well, we're going to test this gallons of gas variable for the Sentinel. So I'm going to make the stop condition while gallons is not equal to -1. Let's see what we've got now. Ask the user for an amount of gas. If it's not the Sentinel value, then we can ask them for the miles that they drove on that much gas. If they enter -1, it doesn't make sense to then say, how many miles did you go on -1 gallons of gas? So if we get to here, if we get past getting the gallons and the miles, then it makes sense to calculate the miles per gallon. And output the miles per gallon. What happens next? It looks like we go back up to the top and ask them for how many miles they drove. And what's missing now is the repeating read. So let's take these 2 lines of code and copy and paste them down in here. Fix up the indentation. So now each time through this loop, we will ask them for the gallons of gas down here at the end. and go back up and ask them for the miles driven. It might feel a little bit backwards to you, and I wouldn't expect you to develop this solution as fast as I just demonstrated it here, but we have now a priming read and a repeating read. Ask the user for the gallons of gas used. If you get one that's not the Sentinel value, ask them for the miles that corresponds to that. Okay, we still don't have all of the spec done, but I'd like us to kind of look at the behavior here. So I'll put a breakpoint. Let's compile this, see if I've got any compile errors. I have some warning messages now, but we'll ignore those. Now, I'm going to run to that breakpoint. Before we get to the breakpoint, we're going to have to enter the gallons of gas. So let's not worry about exactly what values we put in. This time I want us to see what the behavior of the loop is. So we'll just put 10 gallons, 10 miles and 1 gallon of gas. Okay, gallons of gas, let's say 1 gallon of gas. Now, I think what I need to do is to get my local variables window up here. There. This is a little bit better. I don't have much room compared to what you have in your development environment, so I floated my locals window so we could watch the debugging take place. So what did we do so far? We just entered the gallons of gas used, and we see that it has 1.0 in it. And now we'll test that for the Sentinel value. We'll test that for the Sentinel value, stepping through using this button, step over, and it will ask us for the miles driven. So gallons was not equal to -1, and it will go in and ask us for the miles driven. So we're going to say something very simple, 10 miles driven, and then calculate miles per gallon. We can see that this is working. Miles per gallon has 10, and then output the miles per gallon and ask for the next gallons figure. Well, let's just do the same thing again. 1 gallon of gas. We're down at the bottom of the loop. Not equal to -1 is still true. So we haven't entered the Sentinel value. And we ask for the miles driven. So nothing complicated. We're just testing the behavior of the loop. The miles driven, 10. Calculate miles per gallon. For this tank you got 10 miles per gallon again, and we're going to enter. This time let's put the Sentinel value, -1. Enter. Gallons is not equal to -1. Well, we can see that it is equal to -1, so this condition is false, and the loop will stop. Okay, so what have we achieved now? We have a loop that asks for gallons of gas and miles driven, calculates the miles per gallon for the tank, and it asks for the next tank of gas. And when we enter the -1, which is the Sentinel value, the loop exits in the right place. Okay, so we're getting there. We have part of this problem solved. I'm trying to always make more room so you can see the code that I'm working with. Now, what do we need to do? What else do we need to do? We need to calculate the overall miles per gallon. So for all of the tanks, we need to calculate the miles per gallon. How are we going to do that? What you might be tempted to do is to sum up these miles per gallon figure and count how many there are, how many tanks of gas, and then take an average of the miles per gallon. And that won't work. Suppose you had a small tank of gas with 1 gallon in it, and you got 10 miles per gallon. And then you had a huge tank of gas, 100 gallons, and you only got 1 mile per gallon. The correct miles per gallon for all of the tanks of gas, in that case both tanks of gas, wouldn't be the average of those 2 tanks. One tank would have much more influence on the result than the other. One tank should have much more influence on the result than the other. So what we're going to do instead is we're going to sum up all of the miles traveled and all of the gas used, and then we'll calculate the overall miles per gallon using those total figures. So let's declare a few more variables in here. You can make as many lines as you want to declare your variables. Let's have one called total miles and one have total gallons, and then something the overall miles per gallon. How should we write that? The overall miles per gallon. Well, I'll follow my rule. That variable name starts to get pretty long, but at least when I read it, I know what it's going to be used for. It's the overall miles per gallon. Okay, the total miles, this is an accumulator variable, and we're going to initialize it in that case to 0.0. That's a common bug. If you forget to initialize that, you'll find it in the debugger that you're adding junk to you're adding your data to junk that was left over in the memory before you were using it. Let's see now. We asked the user for the gallons of gas. Where should we add the gallons of gas into the total gallons variable? Should we do it right here? Maybe not, because we haven't tested that variable for whether or not it's the Sentinel value. We don't want to add the -1 into the total gallons. So let's go in here and write total gallons gets total gallons plus gallons, and there's a typo. And now, where would we add in the miles? Well, ask the user for the miles. Let's do it right here. Total miles gets total miles, the old value, plus the new data. So we're throwing miles into a bucket called total miles, and after the loop is over, we want to output, let's see if we can make it look like the spec. Your average for these tanks is %.2 LF, 2 places past the decimal. Your average for these tanks is then the number, then miles per gallon. miles per gallon. \n. Let's put a line break there and then put, oh well, we haven't calculated the average miles per gallon yet. How can I be outputting it? Well, we want to output overall miles per gallon, but we don't have any value for that. So go back in here and say, well, overall miles per gallon is what? Total miles divided by total gallons. Let's see if this will compile. We've typed quite a bit of code without compiling. And indeed, I have some errors. Good. Let's look for what's wrong. In this window, scroll up to the top. The very first time it says error, double click on it, and it will point at something. Now it's pointing at this line. Do you see any problem with it? It says syntax error, missing semicolon before constant. That kind of doesn't help, but if we look at that long enough, we'd find that I just left out the assignment operator. Okay, now let's compile again. F7. Good. And let's run this using just simple data and see if we have something that seems to make sense, and then we'll test it with the test case data. So I'm going to turn off the breakpoint. Sometimes when I've got some code that compiles, the first time I try it is without the debugger, just to see if it works, and when it doesn't, and it usually doesn't, then I'll set a breakpoint and start going through. Don't spend too much time just looking at the output. We want to go quickly to the debugger to see what's going on when there's something wrong. So the gallons of gas used, suppose I used 1 gallon of gas and I went 10 miles. I got 10 miles per gallon. The gallons of use, suppose I used 100 gallons and I went 100 miles. Then I got 1 miles per gallon. That seems to make sense. And then -1. My average is 1.09 miles per gallon. Does that make sense to you? Almost all the time, I got 1 mile per gallon. Just in this case, when I had 1 gallon of gas, I got 10 miles per gallon. So the answer should be relatively close to 1 mile per gallon. So it seems to be working. Let's try this one with the test case. F5. Now I have to flip over to the test case data, 10.7 and 136.7. .78 seems to be right. I'm using Alt-Tab to flip around in here. Now the next one is 16.85. 16.85 and 184.36. 10.94 miles per gallon. That seems to be right. And then -1 to end should give us 11.65 miles per gallon. And it does. Okay, so it's unfortunate that I didn't make too many mistakes that time again, but let's review the characteristics of this particular problem. We have a priming read, and then a loop that checks for a sentinel value, and then part of the processing of that data was to accumulate the data that was entered, so the total miles and the total gallons. And part of the processing was to do a calculation on that pair of miles and gallons. So the problem starts to get a little more interesting. We had more than one thing to do in this loop. Remember this pattern of the priming read before the loop starts, and then the repeating read occurs right at the bottom of the loop. And this is a technique that allows us to use just one check to look for the sentinel value. And it's kind of nice because we didn't add in the -1. The value -1 went into the gallons variable, but we didn't actually ever process that. We didn't actually add that into the total gallons because we checked for it here. And after the loop is over, we had some more processing to do. We calculated the overall miles per gallon, which was based on these two values which we accumulated inside the loop. It's very likely that as you're typing this, you would want to do more work in the debugger than I did in this demonstration. I think I've typed this solution a few too many times to make as many mistakes as I probably should for a realistic demonstration of how this particular problem solution would be developed. Okay, let's stop here on this one and go and look at another spec. And now one more problem. We're going to look at something called factorials. And in this program, we're going to ask the user to enter a number, and we're going to calculate the factorial of that number. A factorial is the number multiplied by each of the smaller numbers down to 1. So factorial of 4 is 4 times 3 times 2 times 1. And the times 1 doesn't really change anything, so you could think of it as 4 times 3 times 2. So 4 factorial, and you write it with an exclamation point, is 24. And these get very large very fast, so we've decided that we'll only do the calculation of factorial for small numbers, less than 10. And that will be plenty to practice making a loop that solves this problem. Okay, I've started the project again. This is a project called Factorial, and we're looking at the spec for finding the factorial of an integer. And this one is a little bit tricky. If you want to, what I encourage you to do all the time is to pause the recording and go into your development environment with this spec and solve it yourself. And you'll find that it's quite a different process to solve it from scratch than to watch me solve it and to understand the solution. Coming up with a solution yourself is very important, and coming up with a loop that does what you need it to do can be very frustrating, but it's well worth the effort to develop that skill. Well, let's start out with this spec by doing the easy part. We're going to ask the user for a number, and we only need one number, so there is no sentinel value this time. We're going to use looping to calculate the factorial value for that one number. And I haven't declared any variables yet. How about, let's call it number. and we'll scan using %i because it's an int. Don't forget the ampersand. Okay, so we're asking for a number, and eventually we're going to have the factorial of that number calculated. So let's make a variable to put factorial in. And before we're done, we're going to output the factorial. You don't have to do these things in order, like painting a picture. You wouldn't paint the canvas from the top to the bottom, you work the whole canvas. So the factorial %i, let's put a carriage return in there, and factorial. So the tricky part of this then is to get a while loop that has the right behavior. And by right behavior I mean it has to loop number times, where number is whatever the value that the user enters. So if the user enters 4, we want this loop to go 4, 3, 2, 1. And each time through, I'm not sure exactly what we want to do, but we want to do it 4 times. So what I'm planning here is to separate the control of the loop with the calculation of the solution. So we want a loop that will go 4 times if the user entered 4 into number, and then we'll worry about doing the calculation. We want this loop to go number times, meaning if the user entered 4, we want to go 4 times, and we could do this either counting up or counting down. We could go 4, 3, 2, 1, or 1, 2, 3, 4. The problem specification and the test case of using 4 showed us going 4, 3, 2, 1. Let's make a count variable. And remember, we want to, where do we start, where do we stop, and how do we get there? So let's start where the count is equal to the number. Count gets number, and we'll count down. So inside this loop, we're going to go count gets count minus 1. So that's where do we start and how do we get there, and now where do we stop? While count is greater than or equal to 1. And there's many different ways we could have expressed this. We could have said, well, count is greater than 0. But I think we have a loop there that goes number times, which is what we want. And we'll put in here the calculation that we want for the factorial. But before we do that, let's compile. I have no errors. I have a build succeeded. And let's put a breakpoint there. Well, let's put a breakpoint here and run to that breakpoint. Enter an integer, 4, and we've hit the breakpoint. Notice that the other variables, factorial and count, so far have junk in them. And when we execute count gets number, count will become 4, and that's where our loop will start. Now, is 4 greater than or equal to 1? That's true, so we'll go in and subtract 1. So that's the first time through the loop. Count is 4. Count is 3. Count is 2. Count is 1. And this time the condition will be false because count has become 0. And we'll fall out of the loop. And we'll print out that junk in this case. Oh, And we have a runtime error. Good, I'm glad that we have a mistake here. We've used this variable before it was initialized, and it didn't like that we were going to print out this junk in the factorial variable. So let's look under debug and say stop debugging. We'll fix that later. So far what we've achieved is our loop seems to be going the right number of times. So inside here we want to calculate the factorial. So we'll write factorial gets. Now what do we want to multiply by what? And this is the tricky part of solving this. The variable count went 4, 3, 2, 1 each time through this loop. And we're going to want to multiply that value, the count value, by something. Well, what if we did count times count? Would that give us the answer that we want? Let's try it. I'm going to do F7 to compile. We don't have any compile errors, so I'll close that window so we can see what we're doing. And F5. Enter an integer, 4. And let's step. Factorial is now 16. And the next time through, factorial is now 9. This time count is 2 and factorial is 4. This doesn't seem to be the behavior that we want. Let's go back to the spec and remember how we were going to calculate the factorial. 4 times 3 times 2 times 1, and we want the answer to be 24. So what would we multiply by what inside of this loop? We have a count that's 4 times 3. The count variable goes 4, 3, 2, 1 each time through the loop. And what would we want to multiply by that count? Let's try multiplying factorial times count and set the factorial to be initialized to 1. So I'm still in the debugger. I can just stop that and do an F7 so we have it compiling correctly, and an F5. Let's watch the behavior this time. If we enter the number 4, now we've got the number is 4 and the counter is 4, and the factorial starts at 1. So the first time through the loop, the count is greater than 1, it's 4, and we're going to multiply count times factorial. Factorial starts at 1, multiply by 4, and factorial will become 4. Then reduce the counter, and the next time through we'll have 4 times 3. And now we have the factorial is 12, reduce the count, this time through we have 12 times 2. When the count becomes 1, this time through we have 24 times 1, which isn't going to do anything because that's still 24. And when count is 0, this loop is over. And we'll output the factorial, which we know has in it 24, which is the right answer. So again, what happened, this is the trickiest part of this problem. Start the factorial variable at 1 and multiply by the count each time. you might notice that this loop went 1 too many times, meaning that last time through the loop multiplying by 1 didn't contribute anything to the answer. How would we fix this loop? We might want it to go while the count is greater than 1, so that the last time this is true, the count is equal to 2. I'm still in the debugger. I'll just stop the debugging, recompile, and now let's run this again with F5, the integer 4. The first time through we'll have the initial value of 1 times the count, which is 4. Now the count is 3. We'll have 4 times 3. Now the count is 2, and we'll have 12 times 2. The count becomes 1, and because we fixed that condition, this loop will stop now. 1 is not greater than 1, and we'll print out the factorial. So the factorial of 4 is 24, and it seems to be working. Just for fun, let's try some other numbers. If we run this and say, what's the factorial of 3? Hopefully it would be 3 times 2, which is 6. When the count becomes 1, there isn't any reason to execute the loop again. The condition is false, and the factorial is indeed 6. 3 times 2. Well, there are many different ways to solve this, many different ways to formulate this loop. We could have counted up to the number, or we could have counted down. It doesn't really matter. We would come up with the same answer. We could have left in this last iteration where we multiply the whole thing by 1, and the solution is only 1, 2, 3, 4 lines of code doing the calculation. And the tricky part for the beginning programmer is to figure out, well, how do you actually get the loop to go the right number of times, and then how do you, inside the loop, get the calculation to be correct. And again, if you were solving this on your own, it should have taken much, much longer, and it probably would be quite frustrating. Your response, your emotional response to what happens when you come to a frustrating problem, usually in the beginning, how to solve a problem using a loop, is very important. Your response might be, oh darn, I can't get this working, I quit. Sort of an anger response, and your response might be, well, it's not working now, let me change it and try something else and see if I can get this to work, because every one of you can multiply 4 times 3 times 2 times 1 and get 24, and you have in your language now all of the tools that you would need to do those arithmetic operations and output the result. So you know that eventually you will be able to come up with the solution. It just takes quite a long time to get even a few lines of code correct. And that's the skill that you need to be developing in this part of the course. Well, I hope you're getting the feel for solving problems using the repetition constructs, the while loop, that we have to work with so far. And the concepts in this, there weren't any new concepts in this segment, but there certainly was a lot of learning in this segment. And what I hope you're taking away from it is that you should be using the debugger to help you examine what the code is doing. It just makes your life a whole lot easier. You see the mistakes quicker. And the objective is not to avoid making mistakes. The objective is to fix the mistakes as fast as we can. That's just the realistic way that this software development works. So we looked at creating problems with Sentinel controlled loops using the priming read, and we did that in the test scores program and in the gas mileage program. And we also looked at a counter-controlled loop, which we used in Factorial, the Factorial program. And notice that in a counter-controlled loop, it isn't necessary that the spec tells you how many times to loop. In this case, we were going to loop a variable number of times, n times in the case of the Factorial. I hope you've enjoyed this, and I will see you in the next one.